Hello there, and today is Monday, so it is time for our ASP.NET Core for Absolute Beginners course. It's actually the last course today, because as I said, we covered already a lot of ground, and I think that what actually ASP.NET Core Fundamental means, we have covered almost everything. So once again, I guess, also saying this during the last session, but if you followed along all this course and probably if you also did some coding along, or maybe during the week, if you tried to actually implement your own projects based on the structure that we had here, and if you understand all the parts that we actually used and what everything in our solution actually does, then that would actually be very, very okay, at least for a position for a junior software developer or .NET developer. That would be more than enough. Of course, to that, there should also be added some general knowledge about object-oriented programming principles and, well, basic understanding of the C# language, also with aspects, for instance, that we haven't probably covered here in this course, because we have concentrated on ASP.NET Core. And a few things that you might try to actually maybe clarify for yourself regarding C# is what actually a class is, the difference between a class and a value type, or difference between a reference type and a value type, what that actually means when different types are passed in as parameters for methods, for instance. Then also having a general understanding of well, some fundamental data structures, like what is a string, what's specific or characteristic for a string, what's an array, what is list, what's the difference between a list and an array, what's actually the difference between the IEnumerable interface, the ICollection interface, and the IList interface. So these are all very, very basic C# concepts that you would actually have to also get a little bit hold onto. Most of them are also covered on this Code Wrinkles channel in the C# for Total Noobs series or playlist. So you can also check that there. But if everything of this type of aspects are covered, I'd say that you should be really good to go for a junior .NET developer at least. So that's my aim. And today, let me just grab something to drink here. You just see that the session today is really not very popular, so not a lot of viewers. But for those of you who are here, thank you very much for tuning in. I really appreciate that, and hopefully we will be able to get something valuable from this last course that we might have. And also during the last session, I was saying that this is actually one where we will also have at the end a Q&A session, so where you will be able to ask your questions if you have things that are not clear enough, or that you would have to get a discussion going on. Just at the point where we'll go to the Q&A session, then just write things in the chat and we'll try to actually go on to that topics. Okay. Here I say the right one. According to another guy who created own web API tutorial for junior position, I have much bigger app with token authorization, a lot of classes, etc. Of course, how many classes do you have? That actually depends on the API that you're building. And as I was saying, we have just actually went over the fundamentals and trying to understand things. But of course, even this one that we have here, you could extend with a lot of other classes and a lot of other endpoints, like having customers in tables, and well, doing reservations the right way, and maybe dealing with multiple hotels and things like that. So yeah, of course, that's totally up to you. What we try to do here is actually to lay a foundation so that you have something to build upon. But I have never promised that we will make here or create an end-to-end application. Like, that was never actually the concept of this, because that's actually not very easy to cover, and to also not get lost, and to actually fully concentrate on the ASP.NET Core concepts that we need to understand. Because without understanding those concepts, we can't really build apps. And regarding token and authorization, that's really not something that I would expect from a junior to know. That is some fairly complicated stuff, so yeah, I don't agree with that point at all. More than this, because when it comes to authentication and authorization, there is actually not something very, or there isn't a unified model on how to do things, because when you're building apps, you probably also rely on different identity providers and things like that. So how you integrate with them, that is totally separate. And of course, if you have authentication and authorization, you would have kind of like policies, and defining policies, that's a total different concept. So yeah, believe me from my experience that at the junior level, nobody asks from you to actually know that. Okay, he created a complicated models many to many. In my opinion, is not good for noob. Yeah, possibly. Because I created 3 simple app web API and I connected with React. A lot of help with people from Discord. Okay, yeah, I know, and actually that was very nice when you shared that feedback that you could actually connect your API to React. But once again, coming back to that other concept, really, authentication and authorization, nobody would really expect a junior to know. So that's very complicated at all levels. Okay, let's then maybe just start by reviewing what we have here. And we will start actually from describing once again our project structure that we have right here. Because we have created here one solution, which is called CWK Booking. And in this solution, we actually have, as we see, 4 different projects. Now, why we have done that is actually because when we create applications, there is this concept of, well, software architecture. How do we want to architect our application? And when it comes to architecting an application, there are, well, nowadays a lot of fancy approaches that are maybe popular as buzzwords, but not, I would say, as widespread as what we actually did. And this is the approach of an N-layer or layered architecture application. So that's actually what we actually try to do here. And according to these layers or according to this architecture type, we try to actually think about our application on different layers that are kind of like responsible for a certain part of the application. So what we have done here in this case, which is an approach that would totally be suitable for small and mid-sized applications, where for each layer we actually have one project. So it means that from our structure here, we can already see that our application kind of, I would say, has 4 different layers here in this case. But 2 of them could maybe even go, although no, these are actually 4 totally distinct layers. So what we have here is first the domain layer, and we have discussed this in depth during the second session, I guess, because the first was on concepts like MVC, JSON, and HTTP and things like that. But we have discussed then that this domain layer contains actually our classes that define the way that our application should work. And here the analogy that I always like to do is that when you create an application, that's actually something that tries to remodel, I will say, or model actually a portion of the real world in computer code, so or in a way that computers can understand and work with. So that's actually what we are doing when we are developing an application. So in our case, we wanted to do something like a very basic booking thing. So this means that, okay, we would have to think about what actually booking works in a real life, I would say. And then we have to actually translate that in a language that the computers would be able to work with, and that's what we are doing in C#. Now, when it comes to defining exactly what that domain means to us, or what that part of the world that we try to model actually means to us, and this boils down in the end to classes, those will be placed on the domain layer. And therefore here we have classes like, for instance, the hotel class, like we have this reservation class, and we have this room class. So these are all kind of classes that belong to this concept of making a reservation or working with reservations. So that's why we try to model in a language that the computer understands, and therefore we use this type of classes. Now, of course, if you would do here right now something like a banking application, in your domain layer, you would probably have classes like bank account, like, I don't know, interest rate, like loan, like exchange rate, or things similar to that. If you would have an eShop or something like that, you would have then in your domain layer classes like product, like shopping cart, like product item, like order, like shipping information, and things similar to that. So all of these classes actually try to, as said, model a part of the real world in a way that the computer can understand. And those classes that we need to exactly model how this program should work, they all belong here in our domain layer, and therefore we have placed that in our domain project. But more than that, in our domain layer, we have placed then also two different other things. So we have placed two interfaces, like we have this iHotel repository, and this is an interface that kind of like defines what our repository should do, and we'll talk about repositories as a recap just in a few minutes. And the other one is an interface that kind of like defines what a reservation service in our application should do. So those interfaces would regularly, or according to this more traditional layered architecture, they will also be placed here in our domain layer. And for those, we have created two different subfolders like repositories and services. So all interfaces that would kind of like define repositories would be placed in the repositories folder, and interfaces that would define your services, then they will be placed here in the services folder. And that's actually mostly it when it comes to what actually belongs to this domain layer. Now, of course, when you get more advanced, there are a lot of other things that you might add here, like validations, like exception, like custom exceptions, like real domain services, like processing different information inside this domain layer, so without having the need of the database or resources from outside. So there might be a lot of other things coming later to this domain layer, but at its core, this domain layer actually does contain, once again, classes that model the part of the real world that we actually want to translate into computer language. They belong here in our domain layer. And that's what we have done there. Now, besides this domain layer, we have another here, which is called CWK Booking DAL, which is an acronym for data access layer. So this means that this layer is actually responsible for interacting with the database. Now, of course, when interacting with the database, there might be different types of database that you could use in an applications, like maybe a SQL database or a non-relational database that might be also come from different other providers. So that could be a little bit more complicated, but in the .NET world, so when you go to work on real .NET applications for companies, most often than not, you will have SQL Server, and therefore you will also have Entity Framework Core. We'll talk about it just in a few seconds. The idea is that here in this data access layer, we place, of course, everything that is related to our logic of data retrieval and data processing with the database. So we really don't put any class here that doesn't have to do something, at least, with this idea of interacting with the database. Now, what do we have then, of course, in this layer? So first of all, we have this data context class that we have created. And this is a class that actually inherits from DB context, which is an Entity Framework Core class. Cool. Now, what I wanted maybe as a short recap of what actually Entity Framework Core is. And let me maybe, I don't know, go here in this SQL Server Object Explorer. And if I remember correctly, where would be our database? because we can already see our database here. I don't know, databases, and I guess it should be this one. Okay, cool. So right now, okay, we have actually these tables. We see that we have this table: room, reservations and hotels. Now, if we take a better look, actually, what this happens is, let me go to the domain layer just 1 second so that we have it here. So if we look here on the right side, we can actually see that there is a direct mapping between our class hotel and we have a hotels table. Now we have a class reservation and we have this reservations table. And we also have this class room and we have a rooms table. So we see that kind of like the structure that we have in our code right now can also be retrieved or seen actually in the database. Now, of course, the idea is here that, if you wouldn't use any tool, for instance, what you would have to do is actually to, create your classes. That would be one step, and then go separately and manually create the data structure in the database that would help you actually to get or to store information and to read information from your application from there. That would of course mean that you would have to very good or know very good SQL and how to create tables and the T-SQL language and different type of relationships, and not only just understanding how those or what those relationships mean, but how do you actually configure them with constraints that are placed correctly, like for nulls or for not nulls, or for what does our foreign key mean, what referential action should we have. So there are a lot of things that you would have to actually know regarding this SQL world, and of course that would also increase our learning curve. Now the good thing is that of course that was a common problem that all developers and all projects faced when they wanted to develop new applications, because they would have to kind of like invest a lot of time in writing the code, of course, but then also invest a lot of time in creating the database structure and everything around the database. And more often than not, that would also maybe require specialized resources. Like for the code, we would have developers. Then for the database, we would then have something like a database architect or however database specialists. And well, they would also have, of course, to communicate one with the other. And then maybe things wouldn't be as smooth as possible. So that was actually, I don't know, 20 years ago, a very common challenge that really all development teams faced. And what do we actually try to do, at least in our programming ecosystem, whenever we have a challenge that actually all of us face, we try to actually work out some patterns or some libraries that might actually help us to overcome those challenges way easier. So that's the point where actually this concept of object relational mapper came into discussion. What does this actually mean? So if we think about the name itself, object relational mapper, it's fairly straightforward. And what it actually means, it's a tool actually in the end that what does that? It looks at our classes like hotel, like reservation, like room, and based on that classes or on those classes, and based on the way that actually those classes are connected one with the other. And let me show you what I mean by that. If I go here on hotel, we see that a hotel has a list of room. So this means that in a certain way, there is a relationship between hotel and room, of course. If we go to the reservation, here we see that a reservation has a room and it has also a hotel. So it means that there is also some kind of relationship between a reservation and a hotel, and a reservation and a room. And those kind of relationships that we see in our code, they would also need to be replicated, of course, in our database. And when it comes to replicating them into the database, there are these concepts of one-to-one relationships, one-to-many relationships, like we have, for instance, a hotel has a different list of rooms, so we have a one-to-many relationship there. And the reservation, it also has then basically one-to-one relationship with hotel and with room. Even though that might be a little bit trickier, because on the other way around, the hotel has or could have, or you could have several different reservations for the same hotel and for the same room, but for different time periods. So the idea here is that kind of like these ORM tools are these type of tools that look at our code structure that we have here and at all these relationships that we have right now, and they simply try to replicate this in our SQL database without us to actually interact with the database at all. So that's why we nowadays extensively use this type of ORMs. And Entity Framework Core is one such ORM that looks into our code mostly and then is able to replicate or translate that code that we have into a database structure that actually replicates the code as good as possible. Okay, Adelina, thank you very much for the kind words. Okay, so and if we take a look here, for instance, if we see here in the hotel, like we see that, okay, if we look at the columns of the hotel, we see that, okay, it has this hotel ID, which is the primary key. That is kind of like a SQL concept. We didn't talk about SQL here, but well, this is the primarily identifier in a SQL database based on which you can uniquely identify a single resource in a table. That's actually a primary key. But then if we look, for instance, at the room, and if we look at the columns, we see here that, okay, this room ID, it has a primary key, so once again the unique identifier, but it also has this concept of foreign key to a hotel. And that's actually how this one-to-many relationship is built in SQL, based on this foreign key. That can actually in this case also be null. So this means that actually a room must necessarily also have, or could have, like the hotel ID to which it belongs. Otherwise you can't really have a room if it is not, or if it doesn't belong to a hotel. Now if we look from the hotel perspective, we will have one hotel with ID 1, and we will have 10 rooms that have the hotel ID 1. So that would be a one-to-many relationship. And once again, we haven't configured anything here. We just have defined our classes, and then Entity Framework Core, our ORM, has created this stable structure for us. Now, of course, there are different type of or different such tools like ORMs. As I said, when it comes to .NET applications, the most popular that you probably will see in most of the project is Entity Framework Core. So that's exactly what we have used, but there are also others. Like there is one other that's fairly popular called NHibernate, and there is another, but that one in my opinion is not a real ORM. It's what is mostly called micro ORM, because it doesn't really have that many features like Entity Framework. It doesn't really create our database structure based on our classes. It just helps us to actually interrogate and work with the database. But Entity Framework Core, why is it so popular? Because it really is very, very powerful. And as a developer, at least if you are at the beginning stages, it's very, very easy to you actually to focus on your code and learn to code and understand what you are doing there. Because Entity Framework Core will actually take care of everything regarding the database for you, like really everything, like creating tables, updating tables, making the correct relationships, making sure that you don't insert wrong data in the tables and things to that. More than that, it comes with a lot of features, like when you retrieve a resource from the database, that resource is by default tracked. It's called by Entity Framework Core. So if in your code at a certain point you change a property of that resource, Entity Framework Core will already know that when we save the changes, it will have to also update the database. So it's really, really powerful, because it kind of like abstracts away from us the entire a part of really working with the database. And of course, when you get into more advanced scenarios and applications, these very powerful features that Entity Framework Core comes with, of course, everything in programming is a trade-off. It has a big trade-off in performance. Because of course you can't really do a lot of things and be then really high performant. And that's why there might be, as I said, the Dapr Micro ORM, which doesn't have that many features like EF Core, but it's way faster. So when you will get in a little bit more advanced scenarios and more familiar with actually writing applications, you will then start to actually see on your own and experience on your own this type of trade-offs, like the power that Entity Framework Core gives you, but then the lack of performance that might affect your application. And on the other side, if you go for Dapr or other ORMs, then your performance will improve, but your SQL skills or knowledge has to be better. So you will see that kind of like everything in programming is about trade-offs. So once again, that was a very, I would say, well, hopefully small or short discussion about what an ORM is and what Entity Framework Core is, because Entity Framework Core is such an ORM. Then let me close here this structure, because we don't need that for now anymore. But instead I want to focus once again here on this DB context. Okay, Sarah, I think now with .NET 6 is a difference is not much at all. Oh, trust me, it is. It is a very big difference. So Entity Framework Core is slow also in .NET 6. You can't really have that many features and powerful tools and be fast. So I guess Dapr is also in the latest versions something like 70 times faster. And yeah, it's also in Entity Framework Core, it's really painful to really work with stored procedures. It's possible, but it's painful. In Dapr, that is really way easier. So if you just want to use stored procedures or just execute SQL query directly, I would then totally recommend Dapr. In fact, for all production applications that I have been involved in, we use Dapr for retrieving data, for reading data, because then we need everything to be very, very fast. And we use Entity Framework Core for all writes operations, because in those scenarios, the entity tracking mechanism is very important for us to actually make sure that everything is saved correctly to the database. Okay, but coming back here to our data context class, because this is the point from where we started. And here, this DB context, because it inherits a DB context, so we can say that's inheritance. So we can say that the data context is actually a DB context. Now, DB context is a class that comes with Entity Framework Core. So if we have decided to use Entity Framework Core as our ORM for this project, it means that, okay, we have to use its classes and the way that it actually works. And the way that Entity Framework Core works is you need this DB context. And in this DB context, you have actually, well, at least one very important part for us, which is this one, which is kind of like this DB set of hotel, DB set of room, and DB set of reservation. Now, of course, I have said that what Entity Framework Core does is actually it kind of like looks at your code, at your classes, and tries to create then tables for them. But in order to do that, you need to actually instruct Entity Framework Core where exactly to look, because of course Entity Framework Core wouldn't know directly where to look for your classes that need actually to be replicated in the table. So in this DB context, we have this concept of DB set. Now, when we add here a DB set of a certain type of resource, like here hotel, here room, here reservation, what does this mean? It actually instructs Entity Framework Core, hey, I will need certainly a table for hotel, I will need a table for room, and I will need a table for reservation. Or maybe in easier words, that would instruct Entity Framework Core just to say, hey, I want hotels to be in the database, I want room to be in the database, and I want reservation to be in the database. And from this point on, actually Entity Framework Core scans our classes, our hotel, room, and reservation classes, and based on the different nesting of these classes, like in the hotel we have a list of room, Entity Framework Core will be able to infer and know exactly how or what table structure it should create for us. But in order for this to happen, we need to do this. So we need to actually create this kind of DB set. DB set is also a class that comes from Entity Framework Core. So it's a concept that's specific to this ORM. And once again, it kind of like, if we look at our application, this is actually a representation of our tables. Like this is a representation of the hotels table, this is a representation of the rooms table, and this is a representation of the reservations table. But more than that, if we think about our DB context class that we have here, that's actually, I would say, the real database that we have, but in memory of our program. Because when you run this application, of course, when you run it for the first time and you don't really retrieve anything from the database, of course, you won't have any objects yet. But it is, or you could think about like this DB context once the application run is actually like an instance of your entire database, but with empty tables. So it's actually a real logical representation of your physical database in the memory of your application. And what this means that when you actually want to get a resource or a list of resources like hotels, well, Entity Framework Core will retrieve them from the physical database and will place them here in these hotels, which would be the logical representation of the hotels table. So that's actually how Entity Framework Core works, and that's actually what these DB sets are and why they are useful. And actually, for a DB context to work, that's actually all you need. It's this DB set, because the constructor that we have here, and we'll talk about that just in a few minutes. This is a constructor that we have created only because we want to use the DB context in ASP.NET Core in the dependency injection container. Otherwise, we could have even left this with a default constructor or not specify a constructor at all in that case. Now, these two methods that we have here, these overrides for on configuring and on model creating, these are methods that you might use when you go into more complex scenarios of using your database and Entity Framework Core, where you want to really not use the default configurations that Entity Framework Core uses, but you want to override that with some very, very specific configurations and specific ways that your database should be modeled when Entity Framework Core works with that. But right now we actually didn't, or we could run our application even without having this overrides method here in this data context class. So the only thing that we would need is to just inherit from DB context and make sure that we have this DB set. DB set is a list-like structure. Yes, you can say that. So if you look a little bit in DB set, let's actually click or press F12 here. Let's press F12, and that's maybe something that you would actually, I would strongly encourage you to do this whenever you have some things that are not maybe really clear for you what each class does. So right now we just have placed the cursor on the DB set and we have pressed F12 in Visual Studio, and that actually brings us to where this class is actually defined in the Entity Framework Core library. Why I actually wanted to show you that is that here we can look into, well, all the different type of information and members that this class has. But here in this case, we can just use or take a look at the interfaces that it actually implements. So first of all, it implements iQueryable. So that means that we can actually run queries against a type of DB set. It implements IEnumerable, which means that this DB set is kind of like a sequence that can be enumerated through it. And I guess, and it also implements iList source, which is kind of like also what a certain list is. So if you take a look at the interfaces that this class implements, actually you can already understand that, yeah, it's correct. It's kind of like a list-like structure. And the reason why we can say that is, first of all, because it implements IEnumerable. And this means that, okay, that this DB set is a data type that actually provides a sequence of things that you can enumerate through. It also is an iQueryable, which means that you can run queries like link queries against that. And it also implements this iList source, which kind of like means that it is a list. So yeah, that is correct, Adelina. That is a list-like structure, I would say, but it is, let's call it a list that is very specifically configured to work with Entity Framework Core and databases. So that's mostly it for the DB set. And thank you very much for the question. There is here from Sarosh another one. Is there an easy way to always call a method on EF save changes to update flag columns common in all tables at the global level? I'm sorry, but I guess I got a little bit lost in your question. When you call save changes on Entity Framework Core or on Entity Framework in general, all the resources that you have in memory and that have been updated, they will be saved in the database, so you don't really have to do anything. That's why actually Entity Framework is so nice when writing to the database, because it has this concept of entity tracking. But once we go to our services and repositories, we'll go there and discuss a little bit more about how we then save changes. And maybe we can then clarify a little bit also your question and maybe reformulate that, because I really don't get exactly what the question is about. Okay. Cool. So this is our DB set. So that's, of course, once again, we were here in the data access layer, and we said that we place here only classes that have something to do with retrieving data. And the data context, obviously, is the primary way of handling or working with data in our application, and therefore we place that, of course, in our data access layer. But then we have this other folder which is called repositories, and we have here this class which is the hotel repository, and we see that this actually implements this interface that we have defined in our domain layer, which is the iHotel repository. And this is what we call the repository pattern that is widely used throughout .NET applications. I said there are, and once again, probably if you look also at other tutorials, you will also hear a lot of people saying that using the repository pattern is actually very, very bad. And I don't totally disagree with them, and I don't totally agree with them. And if you want to actually get a deeper insight about why I actually think that, there is here a video on this channel which is called "Should we use repositories or not?" And then I go in depth into that type of discussion. But why I think that that's actually a very, very badly formulated piece of advice, because as I said, everything in software is actually negotiating trade-offs. Of course, there are some trade-offs using this repository pattern. There are some trade-offs of not using that repository pattern. You always have to balance and understand, for the needs of your very exact context for which you need to build an application, what pattern you should use or not. And in this perspective, I totally say that for most applications, or for a lot of applications like small, even mid-sized applications, using this repository pattern is totally fine. So it is totally fine. It kind of like decouples your controllers from using directly or from interacting directly with the database and so on. Okay. No, I mean columns like tenant ID, updated on, updated by, that are global to all tables, but don't want to update those columns in every entity. You can create a base entity that and all your types will inherit that base entity, and then that would translate actually in each type of entity having also those columns in that specific table. So yeah, you can totally do that using inheritance. would create something like a base entity in which you would put the property tenant ID, updated on, updated by, and then all of your types, like we have hotel, reservation, and room, would inherit also that one. And that will make all properties by default being on all the tables there. So that's the way how you would achieve that. Okay, but coming back in this whole concept of repositories, and I would maybe just like to go very shortly in our API, in our controller, because if you have watched, I guess it was the third or fourth lesson or something like that, we see that we have this hotels controller, and at the beginning we have injected here directly our data context, and we have used our data context to actually retrieve all the entities that we need, or update the entities, or create entities, and things similar to that. But then we actually discussed this idea, which is totally fine and could happen, that for instance at a certain point somebody comes and say, hey, we just want to switch database, and we don't, or maybe we just want to also switch the ORM. So you couldn't use then the data context anymore, and that would mean that you would have to come in really all controllers. And here we only have 2, but in real application we would have 10, 20, 50 different controllers. So you would have really in all of them to go and replace all the logic that the data context was used for with the new logic, and that would be really terrible to do. It would actually be very painful and hard. And in that case, what the repository pattern actually means is, okay, let's not use directly, for instance, in the controller directly the DB context, which is a very specific implementation of how we work with a SQL database with Entity Framework Core. Let's not have this in the control in our controllers. Let's just expose an abstraction, which is the iHotel repository, and then we implement this class, this hotel repository. And while implementing this class, we of course here use this data context, which is our DB context. But if we get the same task and get, okay, we need to change the database provider or the ORM, cool, you just have to make the changes in the repository. So there would be only one place where you would have to perform those changes, and as long as this class adheres to the interface, no consumer or no other code would be affected by that. So that's actually the main benefit of using this repository. And of course, there are other side benefits that are very important, like it's easier to mock them while unit testing and other things similar to that. How the repository communicates with Entity Framework? Well, it's like this. In the repository, in the constructor, we inject the DB context class, which in our case is called data context. So we just inject it here, and we have this private field. And then for all these methods, you see that we work directly with this DB context. So here for this create, we just get the hotel and we add it to the database and then save the changes. Then we just create the hotel room. In this case, we add the room to the database and save the changes. But for this, we are using actually Entity Framework Core, like in this case, the DB context class. And the way we use it is through dependency injection. We inject that in the constructor of the repository. And we will also once again go through the idea of dependency injection just in a few minutes when we finish with this data access layer. Okay, so then we see that in this repository, once again, we inject the DB context. Now, if you need to switch the database provider or the ORM, what you will need to do is actually just inject the new things that you need here, put them of course in a private field, and in each method just replace the logic that is specific to that provider to a logic that's specific to the new provider. But that would be the only place where you would have to do that. All the controllers that actually use this repository, they wouldn't even have to know that something changed there. That's the main reason why we actually use interfaces. So as long as this interface is kept, everything's okay. We just have to change here the logic that we use to access the database. Okay, I also had a problem with understand this did web API 10 times, but I didn't fully understand. Well, it's dependency injection. It's the very cool thing that we have in ASP.NET Core and that we have not, for instance, by default in regular ASP.NET Framework applications. It's called dependency injection. So we'll just have a talk about that just in a few minutes. But I guess, so right now, is it clear at least that we get our DB context through dependency injection? So we inject it in the constructor, put it then in a private field, and then we reuse it in all methods where we actually need to access the database. So is this at least clear now? Okay. Now, of course, this repository, as we see, also has to do with the data, and that's why we have also placed it in the data access layer application. Sorry, the data access layer project, which corresponds to our data access layer. Hello. How do you solve the conflict data problem when you have multiple requests to update or read the same data at the same time? That is not possible. If you get this type of concurrency errors, then something you are doing wrong. Because actually, Entity Framework Core theoretically for each type of request that you might have will create a dedicated DB context instance, and only that DB context instance will be used to actually work with the database. And the DB context itself does keep track about the order in which different things should be executed. And that's also handled on the SQL Server side. That's why we have these ACID principles in SQL. So theoretically, if you get concurrency errors on Entity Framework, then it means that something is not implemented correctly. Okay, cool. So yeah, now let's then go maybe to the next layer, which is this service layer. And this service layer is actually a very simple one. Here we have implemented just one single class, which is this reservation service. And here in this reservation service, we see that we use dependency injection to inject both a repository and the data context, because in some cases we will need to use the hotel repository. In other cases, we just use the data context actually to do the stuff directly on the database. And if you remember, the reason why we haven't implemented here repositories for all of our resources was that, okay, this was just the example that we did during the lesson, and I specifically instructed you, if you want to actually go in deeper into that, you should implement by yourself repositories also for rooms and for reservations. So I'm not sure if you did that, but if you did that, that would have been really a very good experience for you. However, what I would actually like to do here in this class, actually we just have methods that actually define what it means to make a reservation, to cancel a reservation, and things similar to that. And the reason why we need this service layer is because in most applications, or let's start from the other point. Let's compare, like we have these concepts of hotels and we have these concepts of reservations, okay? And if we look at our controllers, in the hotel controller, what do we actually do here? Well, we do some very easy tasks. When we create a hotel, we just get the hotel and create it. When we update a hotel, well, we just update the hotel and then save the changes to the database. When we delete the hotel, well, we get the hotel by ID and we delete that. Now, further or more than that is just we do some retrievals if we want to get a list of hotels or a hotel by its ID. And that's actually all what we do. So that's everything very straightforward. So, hey, create me a new resource. Hey, update me a new resource, delete me a resource, or get me some bunch of resources. So very easy. That's what is called CRUD, like an acronym that stands for create, read, update, delete, which are very basic and simple operations actually in your system that in the end, of course, also have to do with the database. But if we think about the reservations controller, now things here are a little bit more complicated than that. And let me just open this method here, because when you want to make a reservation, it's not that easy like we had for the hotel that you just have to create something and that's it. No, in this case you would actually have to implement a richer set of features or logics or steps in order to make sure that that reservation is actually correct. And that's something that cannot be implemented in the repository, because in the repository you just need to have data retrieval or data processing logic, but not business logic. Because what it actually means that making a reservation on, or what are exactly the circumstances in which a reservation can go through, that's something that belongs to what we call business logic. So it actually doesn't belong to the database concept, it belongs to our application itself. What's the logic for that? So in services, we use services whenever we have more complicated tasks to perform that require usually operations across different resources from the database. And we can take this method here, like make a reservation. So here, in order to make a reservation, we have to actually do a lot of stuff. Now, first of all, we would have to get the hotel for which we want to make the reservation. Then we will have to get the room for which we would like to make a reservation. Then, of course, we have to check that those hotels and the rooms that they really exist in our database, because otherwise, obviously, we cannot perform a reservation. So we have to do this check here. In our case, we have just chosen that if they are not in the database, so if they are null, we just return null, and our controller will know that the reservation was not possible. But then we have, for instance, another step. We have to check, okay, I want to make a reservation for this room that belongs to this hotel, but is this room available? So in this case, we need to go to the database once again, look for all the reservations, and check reservations for that specific hotel ID. If the check-in and check-out date actually for our reservation is actually in the range of the check-in or check-out of already existing reservations. So that's once again an additional logic that we actually have to do. And if we take a look here, in these three different steps, we have already worked with three different resources from our database. We have worked with hotels using our hotel repository. Well, here we have worked with rooms directly. We have retrieved the hotel, including the room. And then we have just searched for the room in the hotel that was already brought to us by Entity Framework Core, but then we had to interact with the reservations table. So you see that actually in services you usually have things that are more complicated and that require accessing different resources from your database. It's not as simple as like the hotel repository that interacts just with hotels. Like if we would have a room repository that would interact just with rooms. If we would have a reservation repository that would interact just with reservations. So in services, that's not that easy, because in services we usually have most of them or many of them here at the same place, and try to actually orchestrate some logic based on information that of course we retrieve from the database. We process that and we apply our own logic here in the service layer. And for these scenarios where you have to perform tasks that are more complicated than simple CRUDs, then you would actually have to use these service classes that we also have here. Now, working with this is also then fairly easy, and this is why Entity Framework Core is very, very powerful, because at each point here we could maybe update a property of one of the resources, but that would actually not write that to the database. It will only, or things will be persisted to the database only when we call this save changes method, or in our case save changes async, because we have used an async method here. So only when we invoke this method then all the resources are actually saved to the database. Only at this point there is an actual connection made to the database. Prior to that, even if we call update or add, what this does, it just updates or adds that resources in the logical representation of our database, which is our DB context. Like in this case, it will update the room's DB set with that new room or the updated version of the room. In this case, it will just update the reservations DB set with the newly added reservation. So this updates and adds and deletes, we don't have a delete here, but if we would have, that's actually always performed on the logical representation of the database, which is the DB context. And only when we invoke save changes, then the changes are actually saved to the database. Only at this point there is a real connection to the database established, and then everything should be persisted on the database. And that's kind of like this entire layer, like services, will contain only classes that are responsible for doing such more complex operations that are not just data retrieval. They rely on repositories for retrieving data, but they then apply some business logic to that. And those type of classes we will put here, for instance, in this reservation service. If we think a little bit forward, if we would like to actually make this application real at a certain point, of course, customers might also need to actually pay for their stay in a certain hotel. So processing a payment, for that we would have a different service, like a payment processing service that would be responsible for handling payments. What does it actually mean for a payment to be processed? When does it begin? When is it marked as completed? How do we get the information from the bank if everything was completed okay? So you see here, there are a lot of things that we would have to orchestrate together just to make one payment. So that would be an excellent actually use case for a new service in our application. So if we would like to build this type of logic in our application, we would actually come here and create a payment processing service. And of course, we would also create first an interface of that in our domain layer, and that's actually how that would work. Now, question for you: is it clear what's actually the role of a repository and what's the role of a service? Is it clear enough for you? Your feedback would be very, very important here at this point. Because if that's clear regarding this distinction between repositories and what they do, and services and what they do, and why we actually place them in different layers, then we can maybe go over to our ASP.NET Core API and go to the core concepts of ASP.NET Core that we have touched during this course as part of this recap here. Let me just grab another drink here. And okay, good. I see there is for now no questions. So let's go now to our ASP.NET Core application. Let's maybe also close all this type of windows because we don't really need them. Hello, Sergey. Thank you very, very much for joining. I'm surprised that you have joined because this is something for beginners, and as I recall, you're not a beginner at all. But thank you very much for tuning in. Have we touched anything on transactions? No, that's a course for beginners. We haven't touched on transactions at all. But we have used transactions in our other project that we are live coding on, the CWK Social API. That is actually the place where we wrap things into transactions at a certain point, and we have discussed about transactions there. Cool. So let me go then here to ASP.NET Core. Okay, thank you very much, Sergey. And when it comes to ASP.NET Core, the first thing that I would like to actually make a basic recap on, because that's, from my point of view, there is one very important thing to understand. And if you understand that thing, actually everything will seem fairly easy afterwards in ASP.NET Core. So what you actually should understand what happens or what exactly is and what happens during the startup process of an ASP.NET Core application. So right when you deploy it on your server and the server starts that application up, what actually happens there? If you understand what happens there, and it's really not that complicated, then you will see that actually most of the things will be very, very easy to grasp afterwards. And when it comes to this startup part of an ASP.NET Core application, we usually have two different classes that are important. We have this program.cs class and we have this startup.cs class. Now, there is one important thing that I need to mention here. When we started this course, .NET 6 was not released yet. So we have started it based on .NET 5. Now, the thing is, and I know that's something that might confuse you a little bit, but that's not my fault, that's Microsoft's fault, is that until .NET 6, so in all versions of .NET Core, when it comes to an ASP.NET Core application and to the startup, you would have these two classes in every application, program.cs and startup.cs. So that's kind of like a thing that you would already know by heart. You create a new ASP.NET Core application, you would have these two classes. That's a given. Okay. However, Microsoft decided to change things a little bit to make them a little bit more interesting for us. And they decided to actually eliminate the startup class. So if you start an ASP.NET Core application on .NET 6, then you will not have the startup class. You will have only the program.cs class. Don't get confused by that, because regarding what happens during the startup process, things are fairly similar. So the idea is that, okay, they have a little bit changed the appearance, but what exactly happens there, or the steps through which the startup of the application goes, are fairly the same. So there is not really a big difference. There is only a difference in the way that those are presented. Now, as we have worked here on .NET 5, and as 99% of all applications right now are previous to .NET 6, of course, since .NET 6 is 2 months old, we will just concentrate on that one, because even if you go to an interview, everybody will ask you about this type of setup. If you happen to know or be aware that in .NET 6 that has changed, that might be certainly a bonus point, but nobody will blame you at an interview that you don't know the difference, like how the startup is presented in previous versions and in .NET Core 6 or .NET 6. So yeah, that's kind of like an important side note to do. Here, our project use of EF Core for inserting, updating, and Dapper for reading data. Is that a good solution for getting data faster? Yes, I use that in all the applications. I use Dapper for data access and Entity Framework Core for write, but I really never have concurrency problems. So I really never had concurrency problems because of that. Hi user 567270. So yeah. That setup is actually very, very viable, especially when you have to work with resources like grids or things that would actually need to get a lot of data, and if that data is also nested with a lot of relationships, then Entity Framework Core will take a very, very, very long time to generate. So in that case, you can just create your SQL or stir procedure and use Dapper, execute that, and get the result, and it would be maybe even 100% faster. So I use that every day in applications, but I really never had a concurrency problems because of that. Because what SQL does, it actually, you can make hundreds and thousands of concurrent connections to SQL from different sources. SQL will know to process them in the order that they actually were created, because that's the whole type of idea of the ACID principles of SQL. So it would actually take care about what things were done, and theoretically everything in SQL is wrapped into a transaction. So when some work begins to be done, then there is a certain transaction that gets completed, and only when that transaction is completed, then the next one actually is processed. So the fact that you're using Dapr and Entity Framework Core should not create you concurrency problems, or at least till now I really never had those problems, and I had some heavily data driven applications, and I never had this problem in this type of setup. Okay, sorry for the parentheses. Now let's go back to the startup that we have in ASP.NET Core. So when you're starting up an application in ASP.NET Core, like when you run it, when we press this or F5, oh, I actually did press that, so I just wanted to show that. I will close that soon enough, I guess, because right now we don't really want to run that. Okay, so what happens when you click on this button or F5, and when the application is actually deployed or run by a server in Azure, or maybe an IIS server or a Linux server? What happens is that, of course, each program that you write, each program that you write, no matter what type of program it is, desktop application, mobile application, console application, web application, it really doesn't matter at all. It needs an entry point. So you need a class and the method that is the entry point to your application. So that's kind of like standard software. There is no software that can be run without an entry point. That's not possible. Logically, physically, not possible. So what we have in our program class in ASP.NET Core is actually the entry point to the application. So when anybody wants to run that, it knows, okay, that's the entry point, and we need to execute this main method. And if you have also, I don't know, maybe followed my other C# for Total Noobs lessons, or maybe even other tutorials on other channels, you would probably have used a lot of console applications to actually showcase some basic programming concepts. And if you recall, when you were creating a console application, that console application had a program class and the method that was public static void main with a string array args as an incoming param. And that was the entry point in the application. And we have exactly the same thing also here in ASP.NET Core. And the reason why we have this is because in ASP.NET Core, a web application is nothing else than a console application that is configured with a web server and knows how to handle HTTP requests and create HTTP responses. But at its core, an ASP.NET Core application is a console application. So when we hit F5 or press this button here, it happens that this is the entry point. So the first thing that would get executed is this line here, or well, this is the entry, this line here, line 16. Now, what does this line 16 do? This line 16 says here create host builder, and we say that a create host builder is actually another method here. So in the entry point, we just create another method here, or we call another method that kind of like returns us something, and on what it returns, we then run or execute this build and run. So that's actually how your web server, your web application gets bootstrapped. Now, what I want to also take a look is what we have here in this create host builder. So when we create here this host, we say here host create default builder. Now this will create for you a web application with kind of like what it is, or what are default configurations for ASP.NET Core. That would include where is your www root folder, how is routing done, how is logging configured, how is that a development environment, is that a production environment, so reading environment variables. Everything is defined actually here, or happens once this entire sequence executes this create default builder. Now, besides of the stuff that is actually default or created by default by ASP.NET Core with this create default builder, we also have here this other method that is changed, that it is chained to it, which is the create or configure web host defaults. And here we have this web builder use startup, and we specify the startup class, which is our class right here. So what this actually means, it means that during the process of actually setting up your web application, ASP.NET Core does some stuff or configures by default some stuff, but then for other stuff, it actually says, okay, please provide me your configurations in your startup class. And that's where actually the execution is deferred to the startup class, I would say. So right now in the startup class, the constructor will be called, in which we will get the configuration through dependency injection. This is what ASP.NET Core provides us by default, so we don't have to do anything. That comes by default like that, and we have also a property to hold that configurations, and it has two methods: this configure services method and this configure method. So it means that what it happens is that when the program arrives here and says, okay, now provide me the startup class, now it looks in the startup class and it executes first this method, configure services, and secondly, then this method, configure. And then after it executes those methods, the execution of the entire process will actually come back here. It will arrive at line 25. Then it will go back here, of course. It will build and it will run your application. And starting in that moment, you would have a running ASP.NET Core application. So once again, the important thing here, there's some host information and default configurations for ASP.NET Core are done by default. But then for others, ASP.NET Core expects us to provide some custom configurations that we might want to use in these methods, configure services and configure. And that's actually what happens during this or during the startup process of the application. Now we arrive then at this point where we have this configure services method and this configure method. Once again, a very, very first important thing that you should remember always, that you might even get this as a question, is that those methods are always invoked by the program class exactly in this order. So first the configure services and then configure. And this is really important because what this means is that in this method, we can then already use maybe things that we have configured here in this one. If it would be the other way around, that would not be possible, of course. So that's why actually it is important to understand that. Now, also, if we think more conceptually about that, these methods actually do some very or two very distinct and very important stuff for our ASP.NET Core application. Now, the configure services method configures the dependency injection container. Okay, and we'll just have a talk about that. And the configure method configures actually our middleware pipeline. And we have discussed about middleware, and we'll also touch that during this recap right now. So let's maybe right now go here to this whiteboard and let's maybe create a new one. And let's try to understand what this dependency injection actually means here. Now, problems that we might have in applications is that you have a lot of dependencies between different type of classes. And when I think about it, let me maybe go here. No, I don't want to type anything here. No, just delete back. Okay, let me go back here. Cool. So the idea is that there is no big problem, for instance, that in this domain model you have here, for instance, like this hotel, it has a list of rooms. Now, of course, that is dependency. So we could say that this class hotel kind of like depends on this class room because it contains a list of that. But that is not really a very, very big problem because that's actually your domain layer where you model how your entire application actually works. So that would not be a real problem, but a real problem would be, for instance, if we will go into this controller, because what we do here is right now you see that we inject iHotels repository, we inject it using the interface. But if we would depend directly on the repository implementation, like if instead of having iHotel repository here, we would have directly the implementation like that. Of course, I guess I'll have to add a using for that. We will not keep this change because right now we will also have an error here. But the idea is that right now you see that right now we have a dependency on a very concrete class. So right now we can say that actually this controller is dependent on this hotel repository. And why is this actually bad? Because this hotel repository actually is from a different layer. And that kind of like dependencies throughout different layers that are very, very tightly coupled, like class dependencies like we have here, they are not good. They will bring you a lot of headaches when you want to test, when you want, I don't know, maybe to change the implementation of the repository, like in the scenario, for instance, then you would have to suddenly maybe just use a different implementation and not this one. So it would imply that you would have to adapt your controller code to the changes that would happen here in this hotel repository class. Now, if we use the iHotel repository interface, that's a common contract defined in the domain layer. And no matter if developers just switch the implementation, for you it's exactly the same, because you always know that they will have, no matter what implementation is provided, you will know or you know exactly the behavior that that implementation will have. So the problem, or a very big problem usually in programming, is this idea of coupling classes together. And more problematic is when we do this across different layers of the application, because things will get very, very messy then. So once again, as I also said, maybe towards the beginning of this session, is what do we actually do as developer or as a developer community when we have some common problems that all of us face, because everybody faced these problems of, okay, we have very, very hard dependencies between classes that actually cause us a lot of troubles. Well, we kind of try to think about patterns that are then commonly used or solve that problem, and then are commonly used by virtually most of the developers. And for solving this specific problem, with the very tight coupling between classes that could take or give us a lot of headaches, then this concept, which is part of the solid principles, which is dependency inversion, was actually created. And what the dependency inversion principle said is that exactly what we have here, instead of depending on a concrete implementation like hotel repository, you should depend on an abstraction. So iHotel repository. So this is what the dependency inversion principle says. I know probably in most of the theory that you have read so far, it seems to be more complicated than that, but it's not. That's what dependency inversion means. Just not, you should not depend on a concrete implementation of a class, but you should depend on an interface. However, that's the principle. Now, how can we achieve that? Because the problem is, okay, I would say here that I want a hotel repository. And of course, right now for us, it's very easy because ASP.NET Core already knows exactly, and will show exactly how, and knows exactly how to actually provide us with an instance that implements this iHotel repository interface. But let's think just for a second that ASP.NET Core would not have this functionality. So we would say here, okay, we want to depend on iHotel repository, but we need somebody actually to be able to provide us with an instance that implements this interface. Because somebody at a certain point actually needs to create an instance of that. So the technique that was actually created then to implement this, or to be adherent to this dependency inversion principle, is called dependency injection. So that's also the difference between dependency inversion, which is the principle that we should not depend on concrete implementations, but we should depend on abstractions, and a technique to achieve that, which is dependency injection. Now, what dependency injection is actually, and now I will go back here to this board. Let's, for instance, assume here, let me go to the pencil. Okay, we have this kind of like concept, which is called a dependency injection container. Okay, So let's call this, I don't know, DIC. Okay, so what this dependency injection container does is says, okay, guys, we all want to be adherent to this dependency inversion principle. And we all, in that case, have the problem that nobody exactly knows, okay, how can we get instances that implement a certain interface and depend just on the interface, but not on the implementation itself. So that would actually need to be somehow centralized. So the DI container says, guys, I'm here to help. So what you need to do here is to just tell me here, for instance, I have a service 1. A service is nothing else than a class that performs some logic. So let's call 1. Okay, and you just have to say, okay, dear dependency injection container, please take into consideration that I want to have this service 1 to be actually added to the dependency injection container and to be made available for dependency injection using maybe the interface. We'll provide the interface IS1, let's say. And similarly to that, we might have a different other service. And once again, that service would be S2 and would say, okay, dear dependency injection container, if you really want to do such nice stuff for us, also take into consideration that for the service 2, I have this interface, which is iService 2. And of course, there would be, once again, for another one, maybe service 3 here. And it would be exactly the same. It would just say, okay, please also register me here in the dependency injection container. And I have the interface IS3. And now the container has actually, or knows exactly, okay, we have kind of like this combination. We have the combination here, or S1, for instance, with the interface IS1. We have S2 with the S2, so the service, with the interface IS2. And we have also this kind of pairing about S3 with the interface IS3. So right now, after this process, this dependency injection container knows exactly, okay, this interface belongs to this class, this interface belongs to this class, and so on and so forth. And then on the other side, we might have different consumers. Like a consumer could be a controller, for instance. And the controller would say, okay, let's say this controller 1. And let's assume that our hotel repository is S1. So what our controller will do here is, once again, everybody in the setup will know that, hey, we have a dependency injection container. That's how it is advertised. So now our, but it's not S here, it's controller, it's C1, sorry, C1. Yeah, sorry for that. That kind of looks weird. I'm not sure how can I delete that. That's the ruler. Where do I have the eraser? Okay, let's erase that. Okay, so it would be C1 because that's actually the controller. Okay, and let's imagine this is our hotel's controller and it needs this iHotel repository. So what the controller does in this case, it says, okay, I need iHotel repository, but how can I do that? Or how can I get that? And say easy, the dependency injection container says, okay, I'm here for you. Just let me know what you need. And then the controller says, okay, I need something that implements kind of like IS1, which would be the iHotel repository. And in that case, dependency injection container will say, sure, no problem, here it is. And it will provide to the controller an instance of this service. Of course, similarly, we might have actually here this other controller, which is C2, and this one might need these services S2 and S3, of course, through those interfaces, and they will say, okay, I need an IS2. Sure, the dependency injection container will say, okay, here it is, so you can get that instance, and the dependency injection container will also say, hey, okay, you can also get that instance. So that's actually how it works. Now, of course, in service 3, you can even inject service 1. So if you need service 3 somewhere, also the dependency injection container will know that, okay, service 3 will need also an instance of IS1. So you can even nest those resources. This dependency injection container is actually this central resource that kind of like handles everything for us. So we don't really have to take care about that. We just need to provide the information about, okay, that's the interface and that's the possible implementation. However, there is one other very important aspect that also refers back to ASP.NET Core. And that one is actually, okay, this is the dependency injection container. Let's look at things right now from the perspective of the dependency injection container. So we have a consumer like the controller 1 that says, okay, I need an instance of IS1. So, okay, here it is. I'll give you an instance of IS1, which is the interface. But then maybe at some time or while the controller is still doing things with that instance, now there is maybe also service 3 that says, okay, I also need an IS1. And then in this case, the dependency injection container will have like a little bit of a dilemma. Okay, but I already have created an instance of that, and it's actually already assigned to controller 1 to actually use that. So the question is, for service 3, should I create a new instance of this class that implements IS1? Or should I maybe also pass in the same instance? Because in the end, this is a reference type. So what we will pass in is just a reference to a memory location where that object actually resides. So very, very basic programming stuff or .NET stuff. So this is one of the dilemmas that are actually very, very important, because there might be scenarios, for instance, where there wouldn't be any problem, for instance, if, okay, controller 1 uses an instance of S1, and if the controller 3 or consumer 3 or consumer 2 needs also an instance of S1, it could be okay that if it provides exactly the same instance. So that could totally work for a lot of different scenarios. Now, the only scenario where actually this might not work always is, for instance, Entity Framework Core, because it actually does or works with transactions to the database. So in that case, we have to make sure in a certain way that that services or new instances are created in a certain way for different type of use cases that we might have. Now, question for you, is it a little bit more clear what this concept of dependency injection container means? Or do you still have some questions regarding that? Once again, that's really the general principle of how a dependency injection container works and what's actually the role to that. Okay, so in this case, let me go back to Visual Studio. And to our startup. And what actually this configure services method does is nothing else than configuring the dependency injection container. As said, ASP.NET Core has by default a dependency injection container. So everything that we actually do here is instruct the dependency injection container, or we register different type of services with the dependency injection container. So here, services add controllers, that would add controller services. That's an extension method that comes from ASP.NET Core, so we don't know exactly how that is, but that also registers some services in the dependency injection container. Then we have this add Swagger generator that actually provides us with services so that we can use the Swagger UI to actually work with our resources, but also this means that these Swagger services are configured for the dependency injection container. Now, add HTTP context accessor actually is here for making available the HTTP context if we need it somewhere. And then we have this add DB context that will actually use or add our data context to the dependency injection container. So because of the fact that we add it here to the dependency injection container, it means that in the repository, where is the repository? In the data access layer, we can simply request an instance of that. So as long as we have added both the repository and the DB context to the dependency injection container, when we request an instance of the DB context or data context, in our case, in the constructor, the dependency injection container will provide it to us. But in order to be able to do that, of course, we will have to first add the DB context to the dependency injection container, and we will have to add the iHotel repository to our DB context. And that's actually what we do here, and that's how we are actually able to resolve these services in the constructor of other services that are registered here, like the reservation service, or in the constructor of the controller. So that's actually how this or what this configure services method does. Now, the other thing that is still a little bit different here, or that still needs to be talked about, and that actually has to do with this idea or dilemma that we have talked about. So if C1 needs an instance of S1 and C2 needs an instance of S1, should I provide the same instance to both, or should I create two different instances and provide one to C1 and the other instance to C2? So it actually has to do with this dilemma, and how the dependency injection container in ASP.NET Core actually solved that is by introducing this concept of lifetimes. And lifetimes we have here, first of all, we see that add scoped. And what does this mean? So scoped lifetime means that you would create, or you would get from the dependency injection, one instance of the service that you need per HTTP request. So if we get an HTTP request and then we use the repository and we need the data context in the repository, and we use the reservation service and we need the data context in the reservation service. So exactly the same instance of the data context will be passed into both because we are in the same request. So we are in the scope of a certain request, okay? So that does this actually mean? Then there is another lifetime which is transient, and this means you will get one instance when it is acquired, and there is another lifetime which is singleton, and that would create you one instance first time when it is required, and then always provides that initial instance. So what it actually means that if we add something as singleton, an instance will be created the very first time that is actually required, and then really the same instance throughout the entire lifetime of the application. As long as the application lives and it is not shut down, it will always provide that instance when services or controllers will need that. Transient, it will create one new instance anytime somebody needs that, and scope will create one instance for each request, or for each request response, let's say a part. So this is actually this is what those lifetimes mean, and they kind of like solve, as I said, this dilemma about, okay, the dependency injection container should pass the same instance, should pass a different instance, and the resolution here it is that it decides that based on the lifetime actually. How send the connection strings for iHotel repository? You don't need the connection string for the iHotel repository because you have the connection string already in the data context. So in the data context, in options, you get the connection string. How this is done? Because in startup.cs, when we add the DB context, we provide an options, and we say here that it should use a SQL Server, and it should use this connection string that we provide here. So the connection string, you just need to add that to the data context. And then the data context gets injected into the repository, and the data context already has or knows exactly what is the connection string to the database. So you don't need to provide it again. You just need to configure it here, and then the data context will always know exactly what the connection string is, and really you don't need to care anywhere else about the connection string. This is the only place where you need to configure the connection string, and that's basically it. Because you inject, let's say, the connection string into the data context, and you inject the whole data context, including the connection string, of course, in the repository. So this is how things flow here. Cool. So I see that, well, we already covered a lot of stuff. Let me maybe just move also to this one. So when we have finished, or when ASP.NET Core finishes with configuring this dependency injection container, then it passes to this other one, which actually configures the middleware pipeline. Now, what the middleware pipeline is, and I will go here once again to the Blackboard, but here I already have the drawing. It's actually something like that. So what we actually can think about here is that when a request comes in, so this is the client or the consumers that wants to talk to our web application. So here we have the consumer, and here we have the controller that is responsible to actually generate a response for that. Okay, so what it happens is that what we have here, or what ASP.NET Core provides, is that we can imagine this also visually. And this request comes into our ASP.NET Core service. Let's imagine this line here being actually the entry point to that. And it kind of like passes that request through a pipeline until it reaches the controller. Like regular water, for instance, it just passes it through this pipeline. Now, the only thing what happens in this pipeline is that from time to time, there are some classes, there is some code that this request will actually pass through. And then in this code, we can actually perform some tasks based on information that we have in the request. So middleware is actually a way, or are classes that are placed on this request pipeline, and all requests go through all the middleware, and responses, when they are generated, will travel once again to the same pipeline, but of course the other way around, from our controller to the client. So this means that in middleware we can just we can actually inspect kind of like this this request response communication, and if we need to perform any logic here, we can totally do that, both on the request and also on the response, when the response travels back through the pipeline to the consumers. And of course, we had a lesson that was dedicated to that. So if you actually want to go into more depth about middleware, you should go back to that lesson, because we have discussed a lot more things there. And when this pipeline is configured, actually, as said, so after this last point here, the execution of the startup process actually reaches this build and this run. So right after that, you have a running ASP.NET Core web application. So in our case, it would be a web API. Now, in this web API, we have this concept of model view controller, or we have these controllers, well, like for hotel and reservations. And when somebody makes a request, then actually the request will ultimately arrive to a controller and to a specific action that might be actually responsible to generate a response for that request. Now, ASP.NET Core is actually responsible to do the writing, the routing. So when a request comes in based on information on that request, mostly on the URL, or ASP.NET Core will try to individuate, or to find out which controller and which action should be responsible to executing or to creating a response for that. There is an opinion that it is necessary to strive for transient lifetime. Do you agree with that? Certainly not. Totally not. I'm not sure where this opinion comes from, but most of the times, especially when you are using databases, you should have scoped services, not transient. Because if you have transient, then you will have a lot of concurrency issues and problems, and really a lot of headaches. So yeah. In ASP.NET Core, regularly you should mostly have scoped, or things that kind of like require atomicity per each request, like database operations, should be added as scoped services. And by the way, when we add the DB context, like add DB context, that's a method that comes from Entity Framework Core. And Entity Framework Core adds by default the data context here as scope service, not transient, because it's really not the best practice. And in fact, also if you go in all of the documentations and even on Stack Overflow, and then you will get all the headaches that developers had that were trying to actually add the data context as transient service. So no, that is totally not right, especially when it comes to services that actually use databases one way or the other. So no, transient not. At least not for, once again, for services that involve databases. Now, for other services that don't have very, or needs for very, I would say, atomic operations and transactions, you can use transient, of course. There might not be a problem with that, but for services that actually rely or work with databases, you should always have scoped. That's why repositories are added as scoped, and that's why services are added as scoped, because services have or rely on repositories and in the end on the data context itself. Okay, so going back to our controller, the idea is that once again, when a request comes in, ASP.NET Core, based on the URL of that request, actually picks out a controller and a certain action that should be responsible to generate a response. And then the action itself, what we do here in all the API actions here, is nothing else than applying the needed logic actually to create a certain response. Okay, thank you very much, Adelina, for your sticker. Very much appreciated. And that's actually a very, very nice one. Thank you very much. And by the way, as Adelina did this, if you want to support this channel in any way, just below this chat box, you have this super sticker or super thanks button that you can use, and that would also be highly appreciated. But a shout out to Adelina for being the first one and actually contributing a lot of times. I guess in past streams, she always used this type of stickers. Thank you very, very much. Shout out to you. Okay, so going back to this, now in the controller action, the logic that we have is actually very, very simple. Like just in this case, we just use the repositories to get, create, read, or update data. So that's actually what we do here. In the reservation controller actually is also not too complicated logic, because what we do is we use in this case the reservation service to actually perform the actions that we actually need. So yeah, that's kind of like what we do. And there is one important thing here. As you will probably work as .NET developers, you will probably see different projects that you will be assigned on, where in the controllers you will have really a lot of logic going on. That is, for instance, a very, very bad practice. And if there is a time, or if there is time to refactor that, then that should be refactored. The idea is that the code that is contained here in controller actions should be actually as short as possible, because this, what the controller should do, should actually just take in the request. If it just needs to validate something on the request, it should do that validation, but then it should pass in, it should pass something to services that would perform the business logic and return a response that the controller would simply emit or return back to the consumer. So the controller is really only an orchestrator. It shouldn't contain any business logic. So that's actually something that you should strive to, is to have a controller as thin as possible. So that's something that actually need to be accounted for. Now, here in this one, there is one other thing that I would like to cover. And here we had this scenario, for instance, for the get. But even, let's say, for the post, where do we have? Here we don't have post. Here we have post, which is the create hotel. Now, the problem was that we have faced while we have developed this one is that, okay, we want to create a hotel. So now probably the way that this would happen is we have an API. a consumer would make a call to us, and in the JSON body will provide an object that contains the information for the hotel that needs to be created. And in the end, that should map somehow to this class hotel that we have here. However, the problem is that when you create a hotel, or the first instinct that you would actually try to do is to actually reuse this domain class, because yeah, I already have a hotel here, okay. But the problem here is that in this hotel that you have in your domain model, you have some properties that the client actually doesn't need to provide when they want to create a new instance. For instance, they will not have to provide the hotel ID, because this ID is generated automatically by the SQL Server. So nobody should ever provide that. So we should actually not even provide the opportunity for the consumer to even think that they should provide that. Then when you create a hotel, you don't really just create also the list of rooms at the same time. You probably just create a hotel and then add rooms afterwards. So you would also not, you wouldn't need in the JSON body to have a JSON array for rooms. So that would also not be needed. So, you know, we have this dilemma here. Okay, we already have this class here that we could in a way kind of like reuse in our API. But on the other hand, we have here some properties that we actually, they don't really belong there because they are not really needed, for instance, when we want to create a hotel. And then the way to actually solve this is once again a very common programming practice, and is to use what we call DTOs, data transfer object. So what that actually would mean is that, okay, do we want to create a hotel? Okay, we create a hotel create DTO that would actually contain only the information that the client would need to provide in JSON when they want to create a new hotel. So instead of having also the hotel ID and the list of rooms, we just have names, stars, address, city, country, and description. So that's the entire thing about using a data transfer object, is to just expose publicly only information that consumer really need to interact to, and actually not the entire domain model, because that would actually leak a lot of information about the structure of our application, and it will simply expose information that is not required. So that's why we actually kind of like use these DTOs. Of course, right now also there is another video here on this channel is why we use DTOs. It is in the software architecture playlist. So if you want to find out more about that, please then go to that playlist and look at that video, because there we discuss this in depth and we see also possible errors that we might have if we don't use DTOs, and what problems we actually solve with that. Now, before we actually wrap up with this recap is, okay, right now in this controller, we have, okay, use this DTO for the body. So everybody that needs to create a hotel resource will provide us with all the properties that we have described here. So nothing that is not needed, all information that is actually required. Now the problem is that when we actually want to save this in the database, we kind of like need a translator. Like, I don't know, if I don't speak Chinese and I need to talk to a Chinese person, then I would have somebody to translate me what that person says and also translate to the person what I say. So it's exactly the same scenario. We have on the one side the hotel create DTO, and we have on the other side the hotel class. Now in the database, we save the hotel class, of course. Now we would need in this case a translator for us, or for our program, that would know exactly how to translate a hotel create DTO to a hotel. And that's actually why we used a tool or a library that it is called Automapper. And if we look actually in the startup class here, we have here this add Automapper. And this actually adds to the dependency injection container the Automapper services. Now the Automapper services, they actually need only one thing. They just need a profile that defines how that translation needs to be made. So we have this Automapper folder, and here we have hotel mapping profile. And here we say that we want to create a map that will translate a hotel create to a hotel, and it will, on the other hand, another map that will translate a hotel to a hotel get DTO. And the way AutoMapper does this, it will actually just compare the properties, and it will take the properties that are common and put the values or move over the values from one side to the other. This is always the source in the profile, and this is the destination. And of course, there is also a video about how to use AutoMapper in ASP.NET Core. So if you want to find out more about that, you can also go to that one. But that's a last very nice task that we need to accomplish, like using this concept of DTOs and using AutoMapper to actually translate from a DTO to our domain class. And here I see there is a question from Sarosh. Would you create a DTO even for a domain class that has just ID, name, and description that are required to be exposed to the client for input? I mean, if you talk about input, then that would probably be in a regular MVC application, not in an API, I guess. And there we actually have view models. View models are actually very, very similar to DTOs, kind of like 90%. It is really the same concept, but yeah, the idea is that the ID you will not actually, it depends on what actions do you want to do. Because if you want to create a resource like we did here, you don't need to provide the ID. Now, of course, when you get the resource, for that one, for instance, we have this hotel get DTO. Where is it? Hotel get DTO. And that has the ID. Because, of course, when a consumer wants to actually get, for instance, a list of hotels, or they would also like to know the ID of each hotel, because they might want to also retrieve a hotel by its ID. So you see that we have two distinct DTO classes here. In this case for the create, and in this case for in this case for the create, and in this case for the get. And of course, you can create as many DTO classes as you need for each specific scenario. I know there might be a temptation to actually try to, I don't know, why should I have different hotel get DTOs? Why shouldn't I have one that kind of like tries to actually somehow incorporate everything? Well, that's actually not possible, and we should try to actually aim to keep things simple and very atomic. So we have a get, okay, we have a get DTO for that. We have create. Is the create, in the create, is the information exactly the same that we have in the get DTO? No, because when we create, we don't want to provide the ID. Then we create a brand new DTO for that. And the reason why we need to do that and really not try to really couple everything together is because, and here we go to another solid principle, which is the single responsibility. And single responsibility is, okay, the theory says, okay, one class or module should only be responsible for one thing. But in the end, what this actually means is that each class or each method should have only one reason for change. Now, when we have if we would have a DTO that is common, that would be reused also in the get and also in the post. Now, that DTO at a certain point, let's say maybe that somebody says, okay, we need to extend it and include another property for the get. Now, the problem is that if we change that, suddenly we will also have that in the post. So you see that basically when you do a change somewhere, it affects something that is somewhere else. And to avoid that, just keep these responsibilities separately. So we have a dedicated DTO for get and one for create and for update, or maybe also for create or update might be different. So it really depends on each requirement itself. So how do you sync all those DTOs if the domain class changes? Okay. Theoretically, you would just have to configure that in the map profile. And that would actually be it. You should actually think also the other way around. You might also have to do a lot of changes in your domain classes that will actually not affect anything that you will present to the customers. So yeah, in that case, your domain class is changed totally independently. If a change in a domain class at a certain point should actually be cascaded until the consumer that makes a request over API, then of course you would have to maybe make a change in the DTO and then also add that change to the map if it is not mapped by default. But for now, we just have used the same property names in the model and in the DTO to just let AutoMapper do these maps practically by convention. But here you could define property by property, which property from the source can be mapped to which property of the destination. And you could have even more complicated logic about like concatenating different properties, and yeah, you have really here a lot of freedom to do that. But also, if you at a certain point make a change to your domain class, that's actually I don't know, maybe only for the get by ID should also be visible in the output, then the only change that you would have to do is in the get DTO for that one. So once again, you see that it's very atomic. You can very granularly decide exactly if you do a change, what exactly does that change affect. Because if you wouldn't use DTOs, if you make a change in domain, it will then affect your entire application, actually. Because if you add a property, then that property will then suddenly be in all endpoints, and of course that would be a total mess, I guess. So yeah, when it comes to DTO, even I would say, obviously, if you have the exact same DTO that you need for 2 or 3 operations, you can reuse that. But in real application, most commonly, DTOs are fairly specific because the actions are very specific, and then you might end up probably having a DTO per action. So, or at least one DTO per action that actually returns something. Cool. So guys, once again, if you want to contribute to this channel, just to say thanks, here there is that button on below the chat box where you can write your messages, where you can actually say a thank you or use a custom sticker like Adelina did just a little bit earlier. And that would be totally appreciated. However, I just want to emphasize that this will not affect the things that we do here on the channel. So even if you do this, even if you don't do, we will still continue to do stuff here. And furthermore, if you have other questions, because that's actually all the recap of the entire application and the concepts that we have covered throughout 11 lessons. In the description of this video, you also have the repository. And once again, if you are not familiar with that repository, for each lesson, we have actually a dedicated branch, because this way you can see in each lesson exactly what we have implemented. So you have a branch for lesson 2, because that's actually the first lesson when we did write some code. In lesson 1, we just had some theory about HTTP, MVC, and JSON stuff. And then for lesson 3, you will have a branch with lesson 3. So in that case, you can check out those different branches and simply, see exactly in each lesson or what we have done actually in each of the lessons. So just clone that repository and reuse that. And of course, as said, this application is really, we just wanted to actually teach these ASP.NET Core fundamentals, not to create really a full-blown application, because that would require really more than that. But that would also give you a lot of space to practice. As said, the application like it is right now, it only has a repository for hotels. So one thing that you could do is just implement, for instance, repositories for also for rooms and also for reservations. Maybe just implement, for instance, services, maybe, or even for rooms, for instance, just to practice that. Maybe implement a controller for for rooms, maybe implement the idea of customer in your application, that you would have an endpoint that actually is able to create, update, delete, and work generally with customers. So you might even also try to do that. So what we have here right now is a skeleton that you can then reuse and take as a reference to actually build this application out, or of course build your own applications based on what you see in that repository, taking that as a reference, but applying that to the application domain and logic that you are actually trying to build there. Cesar, thank you very much for time and knowledge share. Okay, greetings from Colombia. Thank you very much. Also greetings back from Timișoara, Romania. I'm glad you tuned in. Thank you very much also for that. So also, as said, this is actually the last lesson in this ASP.NET Core for Beginners course. My plan right now is to actually maybe start a new course that would be ASP.NET Core for Intermediates, that would actually go actually, I'm not sure if exactly from this exact same application that we have right now, but at least from an existing application that has the basics just like we have it here, and actually go into some more advanced concepts about model validation, about response types, about custom exception handling, about filters, what are actually filters, into authorization, authentication, into unit testing. So I definitely think I will do such a course. However, that course is not already prepared, so I will have to actually create first a layout for that and try to actually do kind of like a plan for that. So most probably I will start that course at the beginning of March. So I don't think that I would be able to do that prior to that one. But if, I guess probably most of you that are watching right now are subscribed to this channel, so you will get notified whenever something new will happen here. But once again, most probably at the beginning of March, we'll actually start with a new training course, which will be ASP.NET Core for Intermediates. And you are, of course, welcome to also join that course as well. So this being said, if you don't have any other questions, then I guess that would be it. I really thank you very much for tuning in during the entire journey. That was really very pleasant for me to see. Also, when we have started, I guess we had only, I don't know, 2 or 3 viewers, but then some more came along, and Fright One, for instance, already was very, very nice, because he already started to also work on an API based on this course, and even created or used that API to actually connect it to a React application. So thank you very much for that. But there are a lot of other guys and girls that joined afterwards. Some of them even wrote in comments that, okay, they are not able to actually watch that during the lives, but they really watch each lesson each week. So kind of like this community grew a little bit. And I am very, very happy to be able to do this, and to be able to contribute at least with my, well, at the level of my skills, to contribute maybe to your development as developers. That is kind of like a cool thing to say, development as developer. Yeah, but that's kind of like what it is right now. Of course, till March we'll continue the different live coding sessions series that we have right now. Even if those are maybe a little bit more advanced, you can totally feel free to actually also jump into those, because even if you don't understand everything, you can still ask a lot of questions there. And it's also a good thing to be also exposed to concepts that you don't really understand from the beginning, because until you will get to the point to understand them, you at least know that they exist and have a hunch about what they might do. So it's not totally wrong to actually skip that. So if you just have time, join also these other sessions, because I'm sure that in a certain way they will help you to get more and more familiar with the .NET world and ASP.NET Core. So yeah, feel free also to join those ones. And of course, then other than that, we have a lot of videos that we upload weekly, 2 or 3 videos. So I guess there might be some interesting stuff for you. Although I have to admit, lately I have created probably videos that are a little bit more advanced, but that's also based on the feedback of the audience that actually I have received from this channel. Most of them are actually intermediates. Okay, so yeah, I guess yeah, I guess then that's it. Yeah. Once again, thank you very much all for tuning in and being part of this. Take care, stay safe, and see you then next time. So bye.